Hello guys, welcome to the YouTube channel. I'm Krishna Gopal. In the last video, we discussed about the missing value analysis. We calculate how many missing values in every column in the data frame, and then we plot the bar chart as we are seeing here. So in the last video, in the ending of the video, we have talked about that why we need to drop the location and the keyword from our data frame. That means we are only moving with the text and target. So now how to proceed, how to take the next step here. So can we create some meta features? Okay, now there is a one question like we not clean this raw data what we have, like people use the punctuation, people use the smiley, people use many things whenever they write the tweet. So we not perform data cleaning here. We are going to fetch the meta feature, but generally we first clean, then we fetch feature. So the thing is that meta features is also kind of like a number of punctuation, what is the number of uppercase, number of lowercase words in the disaster and non-disaster. So that are the meta features, and that meta features only can extract from the data set if we not perform any kind of a data pre-processing. This is the third video, and in this video we're going to talk about the meta features. Like, let's calculate the length of every tweet and see what the length of a disaster tweet and what the length of the non-disaster tweet. So maybe the length can play an important role to decide if it is a disaster tweet, then it may be the big text, or if it is a non-disaster, maybe it is a small text. So for this I just calculate the length of every tweet. So for this I create the new column, that is a length in the data frame. And how I create df, I have the tweet column, that is a text, then I put the string, and I put the length of string here. Then you can check the df dot head. So disaster, this is the length column, we get the 69 and the 38. We can say when this length creates some kind of good inference from its analysis, then another kind of a meta features also can do this one, and these meta features can help us in our building the machine learning model, because the feature selection is one of the most important factor when it's come to build the machine learning model. So for the meta features, we are going to write one function. In that we are going to calculate near about 7 to 8 meta features, and let's start. So before that, let's see what are the whatever the meta features we're going to write. So these are the following meta features which we are going to calculate. The word count, it actually tell how many number of the words in the text, that is then mean word length, what is the word length mean we have, number of uppercase, number of unique word in the text, number of stop word, URL count, character count, and the last is the punctuation count. So these, how I get to know these are the meta features, you have to go to the Kaggle and you have to read a lot of the notebooks what the people use and how these features are behave and support in the machine learning their model to improve the accuracy. So but these are the features which are very common and will play an important role. But after calculating these features, we going to visualize, and we will see how these features are giving inference from them. Then if some features which are not giving anything to us, we will remove. Some features which we think they are going to be beneficial for us, we will keep it. So let's write the function define create. For this you need to pass the argument df, that is your data, and you can write the doc string that this function calculate the, these are the number of features, meta features this function will create. So first I will count what are the word count we have. So here we are going to use the lambda function, and if you remember and if you watch my Python for data analysis video, there we discuss what the application of the lambda function. So that's come here to use. So we will use the lambda function, we will use the map function, and we will use some kind of a regex to create some meta features. So first we can create the word count. So df, and we have to write the word count. So how many words we have. So df, and you have to pass the call. So another argument, you have to pass the column name df.call, and in this you need to apply the lambda function lambda. And what lambda will be? Lambda will be the length of that string, length of that your tweet. So length of str dot split. So these length it will be calculate, and you can write in the comment number of word count, so it will be easy to know what we are doing. So another one is the mean word length we have. So mean word length. So df have to copy this because last part only will change, and you can write the function, that name of the column, mean word length, and in this you can apply the lambda. Then you can apply the np dot mean. What is the length of your words in your text? So we need the length of w, and what is the w for w in and w in string of x dot split. So this will give you the mean of that tweet. Then next one, we calculate the number of unique words, how many unique word count we have. So for this we need to write the df unique word count. We have to create new column, and we need to apply the lambda function again. So lambda length of set of string of x dot split. Why we use set? Because set will only take the unique word count, so it will be count the length, how many length of that we have. Next we will calculate how many uppercase word we have in the tweet. So for this we need to write the uppercase words, and we need to apply the function that length. We need to calculate the length of how many words are come in the upper, and we write that words in the tweet dot split, and if w is in upper. So this is basically we are using the list comprehension to writing these function, because these are the one line of the function, so that we are using the lambda here. And after that number of uppercase, you can write the number of stop word, how many stop words we have in every tweet. So number of is for the number of stop words, if if w is upper, then it will be calculate for the uppercase, and if w in stop word, then it will be calculate for the stop word. Rest of the syntax will be the same, and if it is in a punctuation, then it will be calculate the punctuation. So this will be the same, but you have to be load the stop words from the Python to the load here, because here mostly we are loading all the important packages. So import a string, and from the word cloud we import the word cloud and stop words, and import re, that is the regular expression. At the later stage we are going to use the word cloud, so here itself we import it, we import it from the word cloud. Then last you need to do, you have to be return your function, you have to be return your data frame. So return df. So after writing this function that create the meta feature, let's call this function and let's see what are the different columns we get in our data set. So how to call? I call it as a meta df is equal to create meta features. So I just call this function to the down. So in the place of the column we write what is our column is text, because from the text column only we want to generate these kind of a meta features. And now let's see how our meta df will look like. So the meta df is we have the word count, we have the mean. For better understanding, just call to. Okay, so we get the word count, mean, word length, unique word count, uppercase, number of stop word, number of punctuation. So these are the column we create in the create meta features. We write the function. So let's see how these functions can add something, or these functions not add any valuable information to our data set. So how we do that inference? So better to plot the KD plot, that is a kernel density function, and we use here the seaborn disk plot, because seaborn disk plot come in this functionality that we easily just need to pass the x and y, and pass some kind of argument, and we can get the disk plot. That is really comes in a good way. So for this do the data visualization. For this I define the figure, and I define the axis, that is the ax1, then plt dot subplots, and I can define the fixed size, that is a 15,6. okay, then I call the sns dot disk plot, dist plot, and you have to pass which like I want to see what are the disaster, how many word count in the disaster and how many words count are in the non-disaster. So for this I write here the df what's my target is the disaster. So I write here disaster, okay, and I write the word count, okay. Then we pass the axis, that is a ax1, and you can pass the color as well. So you can use some kind of a hex color. Hex colors are comes like they are very cool colors to your eyes. So if you write in the Google www.hexcolors, you will get on a website where the lot of hex color codes are there. You can copy and paste according to your comfortability. So what the color I want to give here, I give this color, and there is a one important factor, that is a hist, like a histogram. So for now I will write here the false, and I will show you when I make it true, and I will show you what things will be the change. Then you can do the ax dot set label in the x-axis, ax dot set x label, sorry, and in the x-axis you want to see the word count, you can give this one word count. Similarly you can write the y label as well. So the y label, so y label is the number of tweets, then you can write the figure title, that is the ax1 dot set title, that is the word count, and plt dot show. And one more thing, you can write here the legend, that is the plt dot legend, and you can lock it in the upper left. So this is the word count we get for the disaster tweet. We have this word count here, and we can see like between the 15 to 20 words people mostly are using in this word count. And if I put here the hist is true in place of false, if I put it is true, so we will get the one kind of a histogram. So these are the near about 17 or 18 words are the mostly people are using to tell yes that situation is a disaster situation we have. But for better visualization I will put it as a false here, okay. And same thing I will gonna repeat for the your for non-disaster also, to just change here not disaster, and again I will change here the not disaster. Okay, so this one come as a non-disaster tweets also. So non-disaster tweets are less skewed compared to the disaster tweet. This is what we are getting from the information from this word count. But whatever the information we have, we want it to fetch the more maximum number of the information what we can fetch it. So it's again better to visualize it in form of the box plot also, like how the box plot is varying between the disaster and the non-disaster tweets, because the box plot tell you the 5 properties for this. So I will write we are doing this one as an exercise, then we write in a function, then it will generate all the KD plot, all the dist plot, distribution plot, and the box plot simultaneously. For this you have to be use here the 1 row and 2 columns. So I'm going to draw the box plot in the second column. First row will be showing the dist plot. So how to draw the box plot in the C bond we will see in this step now. And I want to define one more axis, that is the ax1 and ax2, and ax2 in the ax2 sns dot box plot. What is our x? Our x is the target. What is our y? Y is the word count. And what is the hue? Hue is again the target, and our data is the metadata, metadf, right? Then for the colors you can create a dictionary. For the disaster is this color, and the non-disaster is this color, and the line width is a 2.5. okay, so this is basically we get for the for our words count in the disaster and non-disaster. So both the box plot look similar, both the dist plot look similar, and it can add some information while building the machine learning model. But here we did only for the one column, but we create near about 7-8 columns, that is are the meta features. So how we will going to do for the meta features? So better to write one function, or better to write one loop, because once that loop will run, that all the features will draw this distance plot in the box plot. Okay, so for this I'm write the define visualize the meta df. Then I want the column also, whatever the columns we want to visualize. Okay, first we're going to define the figure, then we write the distance plot and the kd plot. What we write here for the particular, but there we write for the generalized case. So better to copy this code from here. Copy this code and let's paste it here, and now make it as a generalized form. So figure, and this is correct. So df, your target will come here, the target, and here also it's come the target. Similarly here also come column. Then so this is the function. Let's run the for loop to visualize these are the meta features. For this we see the meta df dot columns. So we want 0 1 2 3, we want the after the 3. So text, we not want text, so should be slice target length and these all. So let's do the meta df. So we want this data frame, right? So this is our the new meta df. So after running the for loop in this new meta df dot columns one, we get this all the features what we do here. For the word count we get for the all the column. So if you see the length is skewed between 125 to 150, and that's what is telling the box plot as well. Word count already we talked, so let's skip. What the mean word length is also a little bit skewed and having some like the outliers, but it's okay, it's also making sense to us. Unique word count is also okay, but uppercase word is not making sense here, so I think we don't need to keep it as well. Same as the number of stop words we can keep, but number of punctuation we can't keep in our data set. So what we going to remove, we're going to remove the uppercase word and the number of punctuation from our data set to moving further from this analysis. So for this I'm going to do new meta df dot drop. What I'm going to drop, the number of punctuation and uppercase word. So we're going to drop it from the axis that is a 1, and we permanently want to drop, so in place is true. This will be the axis. Okay, so now what we have, new meta df. So we have the target, we have the length, we have the word count, mean word length, unique word and count, and number of stop words. So we have the 6 column, and what the initial data frame we have these columns. So let's do in that way. We have to be drop the keyword and the location. From axis is equal to 1 and in place is 2. So what the df we get the id, text and target. So id text we keep it. So what we want, df 1 2 3. Okay, df dot column should be okay. So we have the id, we have the text, we have the target, and we're going to merge it. We're going to merge it with the new meta df with the left index true and the right index as well true. And let's call as the new df. So let's see what the new df we have. We get here target text, target 5 because we get the duplicate column. So let's in place of 3 write 2, and let's see again. So we have the text. So we have the total 7 column: text, target, length, word count, mean word length, unique word count, and the number of stop words. So with these kind of 7 columns we are going to move further our analysis. And in the next part of the, so this is we discuss about the meta features, visualization of the meta features. In the next video we will talk about the n-grams, and then we do the data pre-processing, that is the data cleaning mostly. Then we move further for the next part of the analysis. So what we cover in this video, we cover the 6 point in this video. So up to the 6 point is covered in our steps. So let's meet in the next video. Up to that, thank you and take care. And if you like this video, then please like, share and subscribe to my YouTube channel, and we'll meet you soon in the next video. Thank you. Bye bye.